Test. Okay. Hi, welcome to the third lesson of flexiWAN Academy. Today we'll cover all about flexiWAN tunnels and path labels. Let's wait a few more moments for more people to join, and then we can start. Okay, so let's get started. I'll switch to the next slide, which is the lesson agenda. So in this lesson, we are going to explain how easy it is to connect multiple sites with flexiWAN using tunnels. We will discuss architecture, tunnel architecture, cover how tunnels work, tunnel encryption options, and also talk about various tunnel topologies. We will be also covering path labels concept, which is used for both tunnels and other flexiWAN features. So with that, let's get started. So I usually like to start these sessions with visiting our documentation pages. So we'll briefly just talk a little bit about tunnels regarding the how they work while showing our documentation pages. So you can get on docs.flexiwan.com, you can get a lot more detailed information, but about every single flexiWAN feature. However, what's important to point out is that flexiWAN uses encrypted IPsec over VXLAN tunnels between sites, and you can get more information about the headers. And I, in general, suggest that you check out the documentation pages for more, deeper dive. But for now, basically, what we can point out is that the tunnels can be created, and both sides, multiple sites can be connected in just a few clicks, which we will demonstrate in this lesson. But what's important is that we support multiple types of encryption, such as pre-shared key, which is enabled by default, IQ2, or no encryption for the faster throughput. We will also touch on ability to establish tunnels behind NAT or using when the device has a public IP. And also we'll explain how basically all sites become interconnected the moment the tunnels connect and establish. All LAN clients can talk to each other thanks to the OSPF, which is enabled by default. So that said, let's move on to the practical part. So here we have a FlexiManage, our central management platform through which everything will be configured. Under inventory devices, we have 3 sites, demo sites. And right now, if you go to the tunnels page, there are no tunnels. And additionally, you can also see, if you go to network dashboard, that we have 3 separate devices, but not really any tunnels between them. No, they're not connected. So let's talk a little bit about how tunnels can be established. So you have multiple sites that you want to connect. The best and easiest way to connect the sites is to click on either specific sites or just the button to select all sites, and then from the actions button you create tunnels, and that's it. The wizard will pop up, the tunnel creation wizard, and it will, in this case, just like for first demonstration, you don't need to even select any path labels or topologies, which is by default full mesh. You just click create tunnels, and that's it. It will create jobs. It will send to all of the devices specific jobs to create tunnels between each of the network interfaces. Of course, this is just a first demonstration to get things started. So the wizard itself is actually a lot more powerful, and we'll cover it. So right now I added a job to create tunnels, and the tunnels will connect in a few moments. And you can see here the encryption. By default, we set it's a pre-shared key. So I wanted to touch on that first. So we support multiple encryption options. And by default, the encryption options are pre-shared key is selected. You can change per organization. Each organization can have their own different types of encryption. So to do that, you actually need to go to organizations, select the organization, and here under tunnels key exchange method, you can actually choose between the encryption options. So as I said, by default, pre-shared key is selected. This is the one that we recommend the most to be used the most. It's pretty much the fastest way to get things working. However, we also support IPv2. There shouldn't be any more differences between them. It's the same way you establish tunnels between sites that we just, but here you can also, just change the encryption method. But what I wanted to say, actually, the method to establish tunnels is the same, just the tunnels key exchange method actually can be customized. And finally, you can also choose no encryption, which is if you run your, if you're using private lines and you don't want to have any encryption overhead, simply go and select no encryption. So you will have the fastest throughput. So that said, we covered the tunnel encryption options. Let's move back here and let's have a deep dive in the tunnels itself. So by default, we created multiple tunnels, and we did it in just three clicks. And here, when we go to network dashboard, you can see actually that these sites are connected. And by default, actually not by default, these sites have actually multiple, some of them have dual WAN, some are single WAN, and this is why you can see multiple lines between them. For example, Tel Aviv and New York have multiple WANs, so there are two tunnels between them, while Tokyo has single WAN, I believe, or it's the other way around. Doesn't matter. We'll cover it shortly. So this is the fastest and the quickest demonstration to show how the tunnels work. But let's delete these tunnels and let's create a bit deeper dive. So to delete tunnels, you navigate to the tunnel page, select all or specific tunnels that you want to delete, and under action you click select. Under action you click delete. And after a few moments, tunnels will be deleted. The device will, of course, sync. We covered syncing in our first webinar. Basically, it means that the device sync to the latest configuration. And in a few moments, the devices will show all as synced. We don't need to wait for that to complete. So let's go dive in. So basically, let's now demonstrate a bit how tunnels work and on a single device. For example, let's go to Tel Aviv. So Tel Aviv device has dual WAN and single LAN. And let me just sort them by type. And also one WAN is not assigned at the moment, doesn't matter. So here we have primary and secondary. This is, of course, lab environment. And, there are no public IP at the moment, but you can basically quickly see what, basically you can manually even add or configure public IP address here if it's not detected. But at the moment we have disabled this because it's a lab environment. So right now we have two WANs here. Each of the WAN interfaces has a private IP, which indicates that this is behind in the lab environment or behind an existing router. So we come here to the first point of flexiWAN tunnels, which is that first important point to mention is flexiWAN can establish tunnels to other devices, even if the devices are between an existing router, if there is some kind of NAT or firewall between them, as long as they can reach each other either via, as long as they can ping external IP or if they're reachable over the internet. Basically, that's the most important thing. So, in order just to point out, so by default, NAT traversal is actually enabled, which is this. Use stun is enabled by default, and this allows flexiWAN to detect the public IP address, which for this lab environment is needed. But in general, how the way it works, it will you can see this even in the log that we have a stun. We have a script that checks detects the public IP and tries to find open ports. So in this case, if the device is behind NAT, it will be able to find an open port. It will be just random port and to enable to establish tunnel to the other side. However, to point out, to get a little bit here back to the documentation, basically all the tunnels, let me see if I can find a nicer map, but basically what I wanted to show, by default, flexiWAN uses because of VXLAN, we use a UDP 4789 port for tunnels. And in case that we cannot, in case that that port is blocked or not accessible, then the stun will just open a random port that it is able to detect. So moving forward, just to repeat, actually to recap, one can have a private IP on its WAN, FlexiEdge site can have a private IP on its WAN or a public IP. We support establishing tunnels also behind NAT. For this, we use stun and NAT traversal to establish tunnels. And however, another point to point out, to mention is that we also support single-site symmetric NAT, which is very common with LTE adapters. So if you can have one site on like with the public IP on WAN or just behind regular full cone NAT, while the other side can be behind symmetric NAT. And in this case, the tunnels will still be able to connect thanks to the NAT traversal mechanism, which is enabled by default. And there is no special configuration for it. It works out of the box. Our goal is basically just to connect the sites the quickest way possible. So moving forward, what you'll find very interesting is that by default on LAN, we have enabled OSPF. This functionality is enabled in order to quickly share routing information, propagate routes between all the sites that are connected. So the moment one site is connected to another, one flexiWAN site is connected to another, we will propagate the routes, and automatically the sites will be able to, clients on the sites will be able to communicate. Of course, if you do not wish that you can that to happen or want to add manual routes, you are free to do so. You can disable OSPF, or you can use a firewall feature functionality, which you can then block or allow just specific interfaces. Also, you can tweak OSPF if you have another OSPF aware device on LAN, such as like such as a managed switch and so on. So moving forward, we have now covered pretty much the OSPF and NAT traversal options. One last thing to cover also is, this is more of a troubleshooting option, is basically this feature here, if you enable, if it works in conjunction with stun. Basically, the devices that connect to the device that this feature is turned on will always send on port 4789. So this is in case, for example, if you have a restrictive router in front of you, but you can still do port forwarding of the UDP 4789 port to the flexiWAN WAN IP. Then you can force the other devices to connect to this device using the default UDP 4789 port. One of the also recommended practices, if you have a device behind, if there is a flexiWAN site behind an existing router, is to either put flexiWAN WAN IP in DMZ on the upstream router, or to have create a port forward for the UDP port 4789 to the WAN IP. This will, make sure that you do not have any interruptions. That make sure that the tunnel is established. So moving forward, let's get back here to the devices. So we have 3 sites, and we shared about Tel Aviv. Let's go to New York. New York has a single WAN. You can see here. As shown before, Tel Aviv is dual WAN, and Tokyo is, I also believe, a single WAN. And all of them are, in a lab environment with different simulated WAN IPs, but private ones. However, what's important to point out here is, pay attention, like each site has a different LAN network and subnet. This is by design in flexiWAN, so there are no subnets or LAN subnets must not overlap, because we use OSPF, and once the tunnels connect, all the sites will be able to talk to each other right away. So we have 3 sites, and let's do some demonstration, and let's learn about all the different topologies, tunnel topologies we support. So let's double check just here. There are no tunnels at the moment, and we have 3 sites that show here on this map as not connected. And in this case, I already demonstrated the full mesh But let's just do it again and then cover the routes propagation first. So I want to connect all these three sites. And notice like that, remember that Tel Aviv has dual WAN, New York and Tokyo have both single WAN. So I select all sites, click Actions, Create Tunnel. And here in this wizard, which we will cover in a more detail shortly, we will just keep everything selected by default, and we will not use path labels right now. We'll cover that also in a bit. And we click Create Tunnels. So here you can see that actually it created 10 tunnel creation jobs. Well, we have just three devices, and if we go here, you can actually see that it added a bunch of jobs. So this, and you can see why actually the reasoning why there's 10. So remember, one site has single WAN, the other site has dual WAN, and we establish tunnels using, if you don't use any path labels, if you just keep things as default, we will establish tunnels using all possible interfaces communication, between all possible interfaces. So there's no need to manually select any interfaces, literally just 3 clicks, and that's it. It will create tunnels, create jobs, and here you can see it created all the tunnels. You can see here that actually there shows a small drop rate, but in a few moments it will show it, of course, to 0. So when you establish, this is a lab environment, so tunnels will connect pretty much really fast. But what I wanted to say is that in a production environment, it may require about 10-20 seconds for tunnels to show as connected, while the tunnels itself in the background will probably be connected right away. We gather some statistics, link fluctuation, or if there's link flapping, and gather a drop rate, and then afterwards it will show as connected with 0 drop rate, as it shows now. So we now created tunnels between these sites, and there's all kinds of information on the tunnels page, which can help you to identify specific interfaces. For example, you can see each device. So each device A, the interface A, device B, interface B. This is how you basically supposed to read it. And here, device A has this IP, which is a WAN IP, and then does not show public IP because there is no public IP, as it's a LAN environment. But if this was a production system, it would show it as well. And it shows exactly what using source port it's using for the tunnel. And you can see the same on the other end. They both use the 4789, which is by default. So the tunnels established using this UDP 4789, if the tunnel is established using this port, this means that there are no blockers in between. The traffic is flowing, and the sites can communicate. What's another thing to mention is the loopback IPs. So beneath each of the name of the device, there is a loopback tunnel IP. A loopback IP, which is actually a gateway on each device for tunnel. So the first hop will be the local loopback, and then the other hop, like for example on Tokyo, is 10.100.04, and on the other device, the loopback will be 10.100.05. Did I say 4? Yeah, so the first one is 4 and this one is 0.5. So, and then if you want to troubleshoot tunnels, which we will be covering a bit later, is you can ping from Tokyo, the loopback or the LAN site or the device itself. You can try to ping 10.100.05, which is remote end. And if it's responding, that means that the tunnels are connected and traffic should be flowing. Of course, the other information here is pretty self-explanatory: latency, the drop rate, the encryption type, which we use by default now, is the default one, which is pre-shared key. But if you would have used IKE or no encryption, you would also be able to select it. You will also be able to see it, and of course, the status, which is the connected device. So moving back now, to explain, we covered basically we analyzed the tunnel page, and now if we go back to the devices page. Actually, not devices, let's go to the network page. We can see that we have full mesh between these 3 devices. And previously I shared that we have, for example, in Tel Aviv, we have 10, 11, 12, some random LAN IP. And because of the OSPF and the tunnels are connected, let's try to find this network 1011 in the routing table of New York. And here you can actually see that the full routing table, and these are the loopback IPs, and of course, because there are multiple tunnels, there are multiple loopback IPs. However, here it is. We can see the 1011 IP is being shown, 1011 network is being shown, and actually not just from one loopback, it's actually gateway, there are two loopbacks. Why? Because it's one loopback is the direct loopback to Tel Aviv. The other loopback is through Tokyo. So for example, if let me go to the dashboard, it's easier. For example, if the Tel Aviv and let's do it like this to make it more easier. So if the Tel Aviv links between New York and Tel Aviv, or even though there are multiple ones, if the multiple tunnels, if the both links are down, New York will be able to still reach Tel Aviv through Tokyo. And all of this is done automatically. So remember, I just clicked connect tunnels, and that's it. All the tunnels have been connected in three. There were no manual configuration. I didn't need to select through which interfaces. It just used all possible interfaces. And here you can. Then there's a lot of work in the background under the hood, which basically monitors all the tunnels. And if one link breaks either between each of these sites, it will be able to still connect through the other site and automatically. So, as explained here in New York site route, we have full routing table. We see all the loopbacks, and we also see the routing. We also see the LAN networks of the other sites, thanks to the OSPF, and it shows which exact interface it's using and so on. So that basically covers the first part, which is the let's just recap. We talked about OSPF, the importance of having OSPF enabled by default. OSPF can also, remember, be customized for if you have another OSPF aware device. We also covered about tunnels page, showed how it works, and of course we showed previously about all types of the supported networks, such as public network, private network, as in this example, or just if you have a devices behind net or symmetric net. So let's focus a little bit more on topologies. So here we demonstrated full mesh topology. So let's delete all of these devices, and let's use our wizard to connect these sites using different topology. So again, we want to use these three sites. Of course, you need more than two sites to demonstrate the topologies. But imagine, this wizard is very useful. Is the power of this wizard is that when you have hundreds or thousands of sites, then it's just a matter of a few clicks, and you'll still be able to connect all these sites in between them. And to do that, basically, just click on the Actions button, create tunnels. The peer connection is something else. We'll talk about this in a future web lesson. But basically, this is to connect to a third-party IPsec based either cloud or router. But now we're focusing flexiWAN to flexiWAN. So click on the create tunnel, and the wizard will pop up. So the topology by default is selected full mesh. However, which we demonstrated already twice. However, we also support hub and spoke topology. And here it will actually change it will show you the small icon to show you how it works. And basically all you have to do is to choose the hub device. In this case, because we do want to create a hub and spoke topology, we want Tel Aviv to be the hub, and other two sites will be remote branches, one New York, one Tokyo. Create tunnel. That's it. Notice, because hub and spoke, hub and spoke now has less jobs added, because we don't need tunnels we don't need full mesh, so we're just using hub and spoke. If we go here, situation is pretty much the same. Some tunnels are already connected, some are not. We will in a few moments. But if you go here to the devices page, now you can see the hub and spoke topology. And again, it's pretty much the same way creation, using the same wizard, just in a few moments, a few clicks, you can reach either full mesh or hub and spoke topology. So in this case, Tel Aviv can be the main site, and Tokyo and New York are branches. Here, because I clicked while the tunnels were not still connected, it shows the dotted line. So this is also important to point out. The tunnels that are not connected will be represented by a dotted line. The full line will be the connected, the established tunnels. And actually, if I go now back, that's it. Now the tunnels are connected. So this is just a demonstration of how fast and quickly you can change between full mesh or hub and spoke topologies. But however, if you have many more devices, then you can combine, and you can combine both, have branches into local full mesh, then the main branch connect to the full mesh to the other to the hub and spoke using hub and spoke topology and so on. So yeah, to recap, we now demonstrated the topologies, and so we covered full mesh and the hub and spoke topology. However, this is not, we're just getting started. This is we're nowhere to the near the end yet, or to showing the power of the flexiWAN tunnels. So let's delete all the tunnels. So here we demonstrated using the wizard used just by default all available interfaces, and it established tunnels. However, what if I don't want to use all interfaces? For example, in this case, Tel Aviv has 2 WANs. What if I only want Tel Aviv to connect to New York using this interface, and this interface using the Tokyo, using the secondary interface to connect to Tokyo? Maybe this line is faster towards the New York, and this line faster towards Tokyo, or there could be any other types of reasons. And for that, for more granular tunnel control, we use path labels. So now we'll focus on path labels, and this will just to explain what they are and how they work, and then we'll get back to the tunnels and we'll explain how to use them with tunnels. So path labels, definitely go check out their documentation. In a nutshell, path labels offer a powerful way to organize networks and tunnels in flexiWAN. They're not just used for tunnels, they're used also for path selection, which is our application-based routing in flexiWAN. However, we'll now, in this webinar, we're just going to show you how path labels work and operate and what they're for, but we'll focus on using path labels with tunnels. Later, we'll show, in the later webinar, we'll have a separate webinar for using path selection, which of course will cover then the use of path labels with path selection. So as I said, this is just a logical way to identify and label each interface. And basically you can go to, let's say, Tel Aviv, and in the path labels, because I already have some labels created, it will show a drop down of all the labels that are created and that are previously created by me, but we will also cover how to create path labels. So it's a logical way to identify and label each WAN interface. Think of it as a post-it sticker or a label which you add on a sticker. Like if you have a network labeler, and you probably, as a network engineer, you probably have a network labeler, and you do ISP1, ISP2 label and print those labels and stick them to the router or switch or whatever. This is literally this. And this is just a logical way. So this is just, literally label. The path label by itself does not do anything. It has just an identificational, it just allows you to identify this interface. However, thanks to the flexiWAN, you can also then use these path labels to establish tunnels using the selected path labels. And in another feature, path selection, you can then also route outgoing traffic to specific path label, which in turn is assigned to a specific interface. So let's basically create a few path labels. So let's go to path labels. And here I have a bunch of path labels just to demonstrate, to give you ideas of what you can do. You can name them anyhow you want them. I usually prefer ISP1, ISP2, 3, doesn't matter. You can use that as primary production traffic, secondary, and so on. But it's, again, it's a logical way. However, when you create new tunnel or when you create new path label, there are this section here is the very important one. So we support 2 types of path labels. One is a tunnel path label. So self-explanatory. This path label is used to establish tunnels between sites. So you can label each interface and then establish tunnels using these path labels. I'll show that in a bit. The other path label type, which is not needed for this lesson, but I'll definitely cover this in later lessons, is the direct internet access or internet breakout. So if you enable this checkbox, then the path label will be applied on the interfaces to enforce the traffic to internet breakout, to use internet, to local internet breakout. So in this case, this is used with path selection. So you want to force traffic through specific outgoing internet facing interface without traffic going through tunnel. For example, I want to route all company routing, company accounting software through a specific, label. Of course, it makes more sense to do it through a specific tunnel, but just an example. But here we'll keep this off for now, and let's create a new label. So flexiWAN Academy description. You can choose your own color, or you can even add, and you click add, and that's it. The tunnel has been added by itself. The path label, not tunnel, sorry, that's it. The path label has been created, and by itself, this page does not do anything. You still have to apply specific path labels. So we'll use one of the existing tunnel path labels, which is the ISP1 and ISP2. So let's go to Tel Aviv. So I want to, so again, the use of path labels is twofold. While we're focusing here on the tunnels, this also the same path label can also be used for both tunnels and also for path selection, which we'll cover in later webinars. So this is the primary interface, and it's primary because it has the lowest metric. This is how you actually decide which interface will be the primary. And you say ISP1. You can type or select. And this one will be ISP2. So we have now labeled this device interfaces, this dual WAN device, and we have, it's ready. You click update device, and be sure to always click update device after adding the path labels. And now this device is ready to connect. So a question, how can I connect this device to New York? Let's try. Let's see what happens. I want to connect Tel Aviv to New York. And if I click to create tunnels, and if I just click here, create tunnels, it will say, no tunnel jobs, no tunnel creation jobs added, because there are no path labels specified on some devices. So this comes to the most important point. We come now to the most important point with path labels, and that is that interfaces with path labels can only connect to the tunnels using path labels can only connect to the other identical path labels. So if Tel Aviv here has ISP1 path label or ISP2 path label, it can only establish to the other end, which also has this same path label assigned. So if I was to connect Tel Aviv to New York must have this path label as well. And I can do here ISP1. So this is ISP1, primary ISP. However, absolutely nothing is stopping you to assign multiple path labels on one interface, which we're going to do in this case. And here, and I'll show that in a few moments why this is actually very useful. Here we added two ISP1 and ISP2 path labels on the New York. And let's also go to Tokyo, but on Tokyo, I just want ISP2. And let's update this. So now we have assigned all the path labels. So let's try to do the same thing as we tried before. We connect Tel Aviv to New York using path label. So path labels, if you click here, it will show you all possible path labels that we have created. And now you have to choose which path label you would like. So just actually, let's take a small step back. The purpose of also the path labels is that you can, in advance, configure label each interface as you wish, as you feel it's good, like to distinguish primary from secondary interface. And then you can create tunnels using only interfaces you wish. So for example, in this case, I would like New York to connect to Tel Aviv using only the better ISP, like the primary ISP, which is ISP1. Click create tunnels. To now create just two jobs, one job for each side. And in a few moments, if we go here to tunnels, a few moments, this will show us connected. And if we go here to network dashboard, we have a single site, a dotted line with the color of the path label itself used between Tel Aviv and New York. And in a few moments, it will connect. Sometimes it takes a little bit more to grab all the statistics, but it will connect. So what I was saying is now we have connected Tel Aviv and New York using Tel Aviv's primary WAN. The secondary WAN is not connected, and New York's only WAN. But as I said, New York also has ISP2 connected, ISP2 assigned, even though it has a single WAN. So the purpose of this actually would be that you want to connect New York to Tel Aviv for redundancy, because even though New York does not have redundant interfaces, Tel Aviv has. So in case Tel Aviv's primary ISP goes down, traffic, if we now connect ISP2 to New York, we will be able to we will still have ability to sites branches will be able to communicate. So I just added another tunnel. So now we have two tunnels. The first one already connected. The second one will in a moment. But here you can see exactly what I was talking about. So even though Tel Aviv has a dual WAN, actually, even though New York has a single WAN, Tel Aviv has two. So we can have tunnel redundancy using path labels if we decide to use all path labels. And in a few moments, yeah, this is now connected. So if we go back here, everything is connected. So what about Tokyo? So Tokyo is far away from Tel Aviv or New York, depending from which side you're looking at. So let's make sure to connect actually Tel Aviv to Tokyo. But now we want to connect Tel Aviv and Tokyo only using the ISP2. And if you click create tunnels, now if you go here, you can see that tunnel is listed. It will connect in a few moments. Here we go. So now we see that the Tokyo is using the blue label to connect to Tel Aviv, and it's connected to Tel Aviv's ISP2 labeled interface, which is the secondary interface, which is probably has a better routes to Tokyo than the primary one, while the New York is connected to both. So here we have basically a demonstration of hub and spoke using the hub and spoke topology using path labels. And in this case, path labels allowed us to have a granular approach, granular way to create the tunnels as we would like to, as not just randomly connect all possible tunnels. No, create what we want. But what I also wanted to bring up is that in case you have either you had full mesh without any labels or granular path labels, if you have multiple WANs, in this case, for example, multiple tunnels, sorry, between Tel Aviv and New York, by default, it will use the shortest route. So that would be the default one. And in case the primary stops working, if it will automatically, so there's no need for anything for the end user to do, or the router or the manager, anybody, flexiWAN will automatically fail over to the secondary interface. And all tunnel traffic will continue working. End users will not even notice. Nobody will notice that actually the primary went down. And just to point out, this is automatically happening on both with path labels or without. If you have multiple tunnels, we will fail over across them automatically. So moving forward, let's cover. So we now covered briefly, at least, we covered path labels, its creation, what it's used for, and also we covered basically how to use them in a smart way, how to decide if you want to have multiple. How to be smart and use interfaces that you wish to use only for tunnels. So I'll delete all of these tunnels again and do one last demonstration, because there was a small label that I didn't explain, which is to select all the devices again, create tunnels. And if I want to select path label, there's an option called all. So this is a magical option because it allows you to create tunnels between every selected device using all possible combinations of path labels that you previously assigned. So the idea behind this is that you have 20 sites with multiple different kind of interfaces. You have ISP1, ISP2, 3, 4, doesn't matter. So you have multiple WANs. So you go ahead and first pre-configure, you create path labels, then you go to each of the device and you assign all possible combinations of that you wish to use of the path labels. And in this case, two interfaces. For example, you have one interface to be primary, you will label them ISP1, the other interfaces will be ISP2, and some devices will have all labels on a single WAN because they have a single WAN. And now with this feature, when everything is selected, you can select all, and you want to create full mesh between all of them. And if I go all of them that are previously configured, and as you can see, because we only have, hold on, let me actually double check this. Tel Aviv has ISP1, ISP2. New York has ISP1 and ISP2 as well. And if you go here, using the network dashboard, you can see that it created a full mesh using all possible labels that it could create. However, let me just double check this. The New York has ISP1 and ISP2, while the Tel Aviv has, yes, so it didn't create the ISP1 for some reason. Maybe I didn't select it, but let's also add it here. This is the idea. Yeah, now it's okay. So basically this is, I don't know why I didn't select, maybe I clicked something wrong, but this is the idea is this is the end goal. So it used all possible combinations of path labels and created everything using path labels it could. One of the things to point out is that you can also, as said previously, you get to choose which path label you wish to use, and you also get to choose the topology you wish to use. So yeah, to cover, we're actually getting close to the ending. To cover, to recap, is that we covered now path labels. We explained how they work, what they're used for. We also covered how to create tunnels between the path labels. And previously, we of course explained the tunnels and everything, how it works, and the architecture and the tunnel encryption options and OSPF, importance of OSPF. So with that, we're actually getting close to the end of this session. Wow, this went by really fast. So if somebody has a question, I forgot to mention, I just dived in, I forgot to mention, if you have questions, we have a Q&A session. So let's actually try to do that now. If you have any questions, I'll wait for a few moments. Otherwise, I think we can close. Just to point out, be sure, whilst we're writing questions, be sure to go to our website, and we have our Academy pages there, and you can actually flexiWAN.com/academy. You can view all the current, all of the previous two lessons, and today's lesson will be also aired at 10 a.m. ET for Americas, and afterwards we will be publishing it here in this section, and you can also see the previous lessons. Just to point out, the next one is on March 15th, configuring application-based routing, and this is exactly what I mentioned in this today's lesson, which is the path selection. So with path selection, we'll also focus a little bit more. We'll again use path labels. So I see there are no questions, so I think we can close for today. Thank you very much. I hope this was informative, and talk to you soon. So in about 15 days. Thank you.